Assalamu alaikum. I am Muhammad Ali Hassan, Senior Lecturer, Department of Mathematics, Milestone College. I hope that student you are well. Welcome to our mathematics online class. Today I will discuss about matrix and determinant, first chapter and higher math first paper. So student, start now matrix. So what do you mean by matrix? A matrix is a rectangular or square array. I say again, a matrix is a rectangular or square array by arranging some number or variable or expression in a number of row and number of column, enclosed by it using first bracket, third bracket or double bar, parallel lines by both sides. So student, let's go. It is three brackets. First bracket is denoted by matrix, it is denoted by third bracket, then first bracket and double bar parallel lines by both sides. So let student here, let a matrix, A is a matrix, here 1, 2, 3, 4, 5 and 6. So student here a matrix is a rectangular array. Here rectangular array. Here enclosed by using third bracket. So here 6 number. So each number is called entry of matrix. Here 1 is a entry, 2 is entry, 3 is entry, 4 is entry, 5 is entry, 6 is number. So each number is called entry of a matrix. Now student, here horizontal line, here two horizontal line. This horizontal line, it is horizontal line. This horizontal line is called row of a matrix. So here first row and second row. So here row, horizontal line. Attention please student, horizontal line is called row of a matrix. So here two horizontal line, so number of row is 2. Then vertical line, here 3 vertical line, so it is called column of a matrix. It is called column of a matrix. Here 3 column. I say again student, horizontal line is called row of a matrix and vertical line is called column of a matrix. Here 2 row and 3 column. So this matrix is called 2 by 3 matrix. First number, it is denoted by number of rows. And second number, it is denoted by number of column. It is expressed number of column. So this matrix is called 2 by 3 matrix. This matrix is called 2 by 3 matrix. I say again student, a matrix is a rectangular or square array by arranging some number or variable or expression in column, number of row and number of column. So enclosed by using third bracket, first bracket and double bar parallel line by both sides. So here 1, 2, 3, this is horizontal line. Horizontal lines is called row of a matrix and vertical line is called column of a matrix. So here 2 row and 3 column. So it is called 2 by 3 matrix. First number, it is express number of row and 3 second number express number of column. So this matrix 2 by 3 matrix. 2 means number of row, 3 means number of column. So it is order of a matrix. So what is order of a matrix? 2 by 3 matrix. 2 by 3. This is order of a matrix 2 by 3. I hope that student you are clear. Student, here what do you mean by row matrix? Row matrix, a matrix which has only one row. A matrix which has only one row is a row matrix. Only one row is a row matrix. So student, what do you mean by row matrix? Row matrix, a matrix which has only one row, is a row matrix. Now suppose A equals to 4, 5, 6. Here only one horizontal line. So only one row. It is number of row is 1. So it is a row matrix. But order of a matrix, here one row and column, vertical line is 3. So column is 3. So order of matrix 1 by 3. One row matrix. So order of a row matrix 1 by 3. 1 is a number of row and 3 is a column. Vertical line, it is vertical line, 3 vertical line. So column, number of column is 3 and row 1. So I say again, what do you mean by row matrix? A matrix which has only one row is called row matrix. Are you clear, student? Next, column matrix. What do you mean by column matrix? A matrix which has only one column is column matrix. I say again, student, what do you mean by column matrix? A matrix which has only one column is column matrix. For example, here A equals to 1, 2, 3. Here vertical line is 1. So column, number of column, student attention please, number of column is 1. And horizontal line is row is 3. But here only one row, only one column, so this is column matrix. And here only one row, so it is row matrix. But here only one column, so here column matrix. Now order of a column matrix. Order of a column, here order of column is 3 by 1. 3 by 1. This is order of a matrix 3 by 1. It is order of a matrix 1 by 3. So column matrix, I say again, student, what do you mean by column matrix? A matrix which has only one column is column matrix. For example, here matrix A equals to 1, 2, 3. Here number of column is 1. So this is column matrix. Then what do you mean by square matrix? What do you mean by square matrix? It is important definition of square matrix. If a number of row and number of column are equal in a matrix. I say again, student, if a number of rows and number of column are equal in a matrix, then matrix is called square matrix. For example, let A is a matrix 1, 2, 3, 4. Here row, number of row here horizontal line, 2 horizontal lines, so number of row is 2, and number of column, vertical line is, column is 2. So here number of column is 2 and number of row is 2, number of column is 2. So it is called square matrix. I say again, student, if a number of rows and number of column are equal in a matrix, then it is called square matrix. Here 2 row and 2 column, so number of column and number of row are equal. So it is square matrix. Another example, square matrix. So look at the board, student. Here A, B and C and D. Student, here two row, number of row, here number of row is 2, and number of column is 2. So student, here number of row and number of column are equal. Here 2 by 2 matrix. So order of a square matrix. Here order of a matrix, this matrix 2 by 2 matrix. So here student, attention please. Here number of row and number of column are equal. So B is a square matrix. So student, I say again, if a number of row and number of column are equal in a matrix, then this matrix is called square matrix. So I hope that student, you are clear. Student, now definition of principal diagonal. Principal diagonal, a square in a square matrix. This is a square matrix. So this diagonal is called principal diagonal. So principal diagonal in a square matrix, so this diagonal is called principal diagonal. This is principal diagonal. Here it is a square matrix by 2 by 2 matrix. So this diagonal is called principal diagonal. Then trace of a matrix, sum of all entries in the principal diagonal. Sum of all entries in the principal diagonal. Here trace of a matrix, student, here trace matrix, trace equals to sum of all the entries in the principal diagonal. So 1 plus 5 plus 9. So trace of a matrix equals to 15. Then what is the trace of a matrix? The matrix here, trace matrix equals to 5 plus 8 equals to 13. So in a square matrix, so this diagonal is called principal diagonal. So trace of a matrix, here all entries, sum of all entries in the principal diagonal. What do you mean by trace of a matrix? Sum of all entries in the principal diagonal. So here trace of a matrix 1 plus 5 plus 9, so equals to 15. Then diagonal matrix. Diagonal matrix. A diagonal matrix is a square matrix. A diagonal matrix is a square matrix with all the entries equal to 0. With all the entries equal to 0 except principal diagonal. Attention please student, what do you mean by diagonal matrix? A diagonal matrix is a square matrix with all the entries equal to 0 except principal diagonal. So student, here diagonal, this is a square matrix. So student, attention please, look at the board. Here all the entries 0. Here all the entries 0 except principal diagonal, or 0 means principal diagonal, 0 or so all entries are equal to 0 except principal diagonal. So this is here all entries are 0, so this is diagonal matrix. Then square matrix, scalar matrix. A matrix is a diagonal matrix where all the diagonal entries are equal. All all the entries are equal. So here scalar matrix, here principal diagonal matrix entry are equal, other entry are 0. So this is scalar matrix. So student, here diagonal matrix, it is diagonal matrix and scalar matrix. Diagonal matrix and scalar matrix. All the entries in the principal diagonal are equal. So here 4, 4, 4, all the entries are equal in the principal diagonal, other entries are 0. So this is scalar matrix. So also diagonal matrix, and diagonal matrix, all the entries are 0 except principal diagonal. So this is diagonal matrix, this is diagonal matrix, but here this is scalar matrix here, because here all the entries in the principal diagonals are equal. So it is scalar matrix. I say again, student, principal diagonal in a square matrix, and this diagonal is called principal diagonal. Trace of a matrix, sum of all entries in the principal diagonal. So trace of a matrix 1 plus 5 plus 9. Then diagonal matrix, all entries are 0 except principal diagonals. So this is diagonal matrix. And scalar matrix, all the entries are 0, all the entries 0, and principal entry of a principal is equal. So this is scalar matrix. I hope that, student, you are clear. Now student, here identity matrix. Identity matrix. Identity matrix. Here, what do you mean by identity matrix? An identity matrix is a scalar matrix with all the entries in the principal diagonal is equals to the 1. I say again, student, identity matrix. An identity matrix is a scalar matrix with all the entries in the principal diagonal is equal to 1. So it is called identity matrix. Identity matrix, it is denoted by I. So for example, student, identity matrix here 1, 0, 0, 0, 1, 0, 0, 1. So here this is scalar matrix, this is diagonal matrix, but here principal diagonal, all the entries with all the entries in the principal diagonal is equals to 1, and other element is other entry is 0. So this is identity matrix. Identity matrix, it is denoted by I or I3 because 3 row and 3 column. And another identity matrix 1, 0, 0, 1. An identity matrix is a scalar matrix with all entries in the principal diagonal. In the principal diagonal is equals to 1. So this is identity matrix. So another identity matrix 0 to 1. It is denoted by I2. This is denoted by I3 1 0 0 0 1 0 0 0 1. It is denoted by I3 or I, and here 2 by 2 matrix here 1 0 0 1. So it is denoted by I2 or I. So I say again, student, identity matrix. Identity matrix means an identity matrix is a scalar matrix with all the entries in the principal diagonal is equals to 1. So it is called identity matrix. I hope that, student, you are clear. Next, zero matrix. This is zero matrix. Zero matrix or null matrix. Zero matrix or null matrix. Zero matrix, a matrix which all entry are 0. So it is called 0 matrix. Now for example here 0, 0, 0, 0. All entries, a matrix which all entry are 0. So it is called 0 matrix or null matrix. So student, you have learned today number 1 row matrix, column matrix, principal diagonal and diagonal matrix, then scalar matrix and identity matrix and 0 matrix. I hope that student you are clear. Student, addition and subtraction. Addition of and subtraction. Let two matrices addition and subtraction if they have same order. Of course, they have same order. For example, here matrix A. Let A matrix is 2, 3, 4, 5. Then another matrix B is 7, 8 and 5, 4. So here addition and subtraction. Student, here square matrix, here 2 row and 2 column. So 2 by 2 matrix, and here 2 by 2 matrix. So A and B are same order matrix. Now addition, A plus B. Attention please student. A plus B, 2, 3, 4, 5 plus 7, 8, 5 and 4. Matrix A is 2 by 2 matrix because 2 row and 2 column, and matrix B here 2 row and 2 column, so same order matrix. Now addition A plus B. A plus B means first entry plus first entry, so 2 plus 7, and second entry plus second entry, 3 plus 8. Attention please student, here addition matrix, here 2 first entry plus first entry means 2 plus 7, second entry plus second entry, 3 plus 8. Now third entry plus third entry and fourth entry plus fourth entry. So student, this is addition matrix. Now we get 2 plus 7 equals to 9, 3 plus 8 equals to 11, 4 plus 5 equals to 9, 5 plus 4 equals to 9. So student, this is addition. Answer will be 9, 11, 9 and 9. I hope that student you are clear. This is addition matrix. Now subtraction. So student, this is subtraction matrix. Here A minus B. This is A is a 2 by 2 matrix, B is a 2 by 2 matrix. So here same order matrix. Now A minus B equals to, here A minus B. First entry 2 minus first entry 7 and 3 minus 8. Then third entry minus third entry, 4 minus 5, and fourth entry minus fourth entry. Student, attention please. Subtraction, first entry minus first entry, second entry minus second entry, third entry minus third entry, fourth entry minus fourth entry. With the same position, then we have here 2 minus 7 is minus 5, 3 minus 8 is minus 5, 4 minus 5 is minus 1, and 5 minus 4 is 1. So subtraction answer will be minus 5 minus 5 minus 1 minus 1. I say again student, here A minus B, 2 minus 7, first entry minus first entry, so first position, second entry minus second entry, so second position. Third entry minus third entry, so third position. Fourth entry minus fourth entry, so fourth position. So result will be another example, student. Here another example. Now A matrix is A1, B1, A2, B2, and B matrix C1, D1, C2, D2. So addition A plus B equals to A1, B1, A2, B2 plus C1, D1, C2, D2. So here first entry plus first entry, A1 plus C1 in first position, and second entry plus second entry in second position. Again third entry plus third entry in third position, fourth entry plus fourth entry in fourth position. This is addition. Here 2 by 2 matrix. Here A is a 2 by 2 matrix, B is a 2 by 2 matrix, 2 row and 2 column. So 2 by 2 matrix. Here 2 row and 2 column. So this is the same order. So addition here A1 plus C1, B1 plus D1, A2 plus C2, B2 plus D2. I hope that student you are clear. Next, subtraction. This is same order. So A minus B equals to A1, B1, A2, B2 minus C1, D1, C2, D2. So here student, here first entry minus first entry, and second entry minus second entry, and third entry A2 minus C2 and B2 minus D2. So answer will be here. So I hope that student you are clear addition and subtraction. So any question, any line, any question, please ask me. So see you again. Allah Hafiz.